Here I come bearing great news. The limits of polynomial and rational functions. Let's take polynomial functions first. If p is a polynomial function and c is a real number, then the limit of p of x as x approaches 0 is simply p of c. What does that mean? If you have a polynomial, then you can just plug in directly. You can use direct substitution. Isn't that wonderful? Why? Because it's easy. We can find the trend in y. That's a limit very easily, direct substitution. Similarly, for rational functions, if r is a rational function given by r of x is some function p of x divided by some function q of x, provided that c is a real number and q of c does not equal 0. Remember, wherever the denominator of a rational function equals 0, we have a vertical asymptote. If those conditions are met, then the limit of r of x as x approaches c is simply direct substitution, r of c, which implies p of c over q of c. The great news is for polynomial functions and rational functions that don't have a 0 in the denominator at that particular x value, we can use direct substitution and our life is so easy. Using these rules, we can find limits. Oh, it's a limit of a polynomial. Direct substitution is in order. -1 squared plus -1 minus 6. Now, I realize from this that this is going to give us 1 plus a -1 minus 6. And these will go off to number heaven to leave us with -6. Now, if I did this graphically, I would see that as I squeeze in on x equals -1, the y is trending towards -6. That's what this means. Here I have a rational function, p of x over q of x, where if I do direct substitution, I don't get 0 in the denominator. So I can use direct substitution here. -1 squared plus -1 minus 6 divided by -1 plus 3 gives us, again, this would be 1 minus 1. These will cancel to give us -6 over 2 is -3. And that is my limit. If I did this graphically, I would see that as I squeeze in on -1, the y is trending towards -3. Does the limit exist? Yes, it's -6. Is it reached? Yes, because I know I'd have a point there. Does the limit exist? Yes, it's -3. Is it reached? Yes, also -3 because I don't have a hole there. Because I can find this. How do I know if there's a hole? I'd get an indeterminate form 0 over 0 when I did the direct substitution.